The right-hand side of a formula in PowerOLAP can do both intercube and cross-cube formulas. A cross-cube formula allows you to reference a value or a point that exists in another cube within the same database. There are some implications with doing this and what happens within the right-hand side of a PowerOLAP formula when you do this. In talking about this, the biggest issue to be concerned with is that the dimensions that are shared between the cubes are not necessarily the same, nor do they have to be the same. There are many instances where you actually don't want the dimensions shared between cubes. In this demonstration, we're going to talk about what happens when you have cubes with different dimensionality and how you write formulas to reference those different dimensions in those different cubes. And we're going to introduce the concept of shared dimensions and what shared dimensions mean and what they do when you have cross-cube formulas. So I'm going to tile two slices. This is a model we saw earlier where we developed an exchange rate cube and used that exchange rate cube to calculate an exchange rate for the future year model. In this example, we shared many dimensions between the two different cubes. However, we also added another dimension called exchange rate. Let's look at the formulas we wrote. And if we look at the formulas we wrote for future year model, you can see that in this example, we did not reference any of the many of the particular dimensions that are shared across these different cubes. How does PowerOLAP know what value to go get in the exchange rate cube when it does a calculation? Let's remember that when you do a calculation, you're looking at a current point. When you ask for a point and it comes into this calculation, even though we're only specifying that we want to calculate the sales adjusted by exchange rate, when a point comes into this, it is a fully qualified point. Once again, a fully qualified point means that it consists of a member along each dimension. So given this, when we come into this formula with a calculation request, we come in with sales adjusted by exchange. However, we also come in with a value for actual versus budget, months, and regions. Let's look at this example even further. Let's come in and assume we're coming into this calculation looking for actual for January for a particular region. It might be the United States. When we go to get the exchange rate, what PowerOLAP does is it uses those values that we're currently calculating and it passes those to the exchange rate cube. And it tells the exchange rate cube, by the way, if you're using the shared dimensions of actual versus budget, months, and regions, the current value that I'm calculating is for actual for January for United States. The exchange rate cube then looks up that corresponding value from its intersection and returns those back to PowerOLAP. By doing this, we simplify the writing of formulas, not forcing a user to specify that they want to use the current value for each dimension that is shared. In other words, when you do cross-cube formulas, the term current is implied in the formulas. For those examples where a member exists in the other dimension that's not in the current dimension, you should specify the intersection that you're looking for. In this case, we're looking for the exchange rate value. There may be other values in the exchange rates dimension in the exchange rates cube that we're not going to use. But to be clear and precise and tell PowerOLAP exactly what to do, you should specify that you want to use the exchange rate value. If you do not specify this value, you will receive a pound name error when you try to execute your formula, indicating that PowerOLAP does not know what value to use from that additional dimension. In this instance, we only have one dimension that's not specified. If you have multiple dimensions that exist in your second cube, in this example the exchange rates, you will need to include a specific point for each of those additional dimensions as well. So to recap, if you want to use shared dimensions across cubes, PowerOLAP assumes current for those dimensions. Unless you want to use a different member for those dimensions, you can simply leave them empty and it will use the current value. If you want to specify a member, you must specify it in the formulas. In this case, a shared dimension that we are specifying is the accounts dimension. In other words, the sales adjusted by exchange is the result value that I want in the accounts dimension, but I want to get my sales value for the accounts dimension. Also, we can see that we're using exchange rates. We want the particular rate value from the exchange rates cube.